Am I on? Yes, I think I'm on. Okay, good. Yeah, so my name is Trond Hindenes. I don't expect you to be able to pronounce my name, but that is my Twitter thing, which I use uncritically to blabber about stuff, so feel free to follow. This story is, first and foremost, I'm not selling anything today. I wouldn't be able to. We only deliver to subscribers in Norway, so there's nothing here to sell. So the reason I'm here is basically to maybe share this story and what we've learned so far with our cloud migration. I think maybe it's a story that's a little bit different than many others. But yeah, like you mentioned, there is this disruption going on in the broadcast industry, and it's both because of competition from Netflix and other giants, but also it's essentially just subscribers or humans wanting to consume content in a different way, and we see that in a big way. Where maybe 5 years ago, our like primary product was this old school antenna-based service. I don't know how many of you still have antennas. Is it called aerials in the UK? Maybe, yeah. But that's not interesting anymore. So this graph at the bottom basically shows our streaming volume from our CDNs, and as you can see, it grows every month basically. This one is from February of this year. I don't know if anyone can venture a guess on what happened in February. It was the Olympics. As you may know, Norwegians are absolutely obsessed with cross-country skiing, so the Olympics were a big thing. And then during the summers, we obviously take off our clothes and run around in the mountains, but then it starts kind of ramping up again. So we're in this transition from like old school TV to this new kind of way of digitally delivering content, and that puts a strain on our CDNs, but it also requires us to be much more professional in our like backing platforms, the APIs that drive our mobile apps, the websites, and all of that like supporting stuff. The graph on top right shows these thumbnail views. We actually deliver 10 million thumbnails per day now just to kind of provide nice content into our apps. And for a tiny, tiny company like us, it feels like kind of a big deal. So we're really kind of seeing this requirement to be much more professional in how we do things. I started at RiksTV 2.5 years ago now. I was a consultant the first year, and then I figured that I'm going to make some unpopular decisions, so it's better to be an employee when you do that. So I took an employee. So I've been employed by RiksTV now for 1.5 years. And around January 2017, we used this old school service provider. So our stack is based in .NET Classic. A lot of it still is, and most of our services were running like bunched together on a few select critical servers managed by a service provider. The service provider we use are really good at delivering like Citrix-based solutions for small and medium companies. They're not that good at delivering high availability streaming platforms. So we had this microservices, but kind of not architecture, because although things were developed as microservices, when you stuff them into the same kind of box anyway, you don't end up with kind of pros of microservice. You end up with a kind of worst of both worlds type of deal. We did have this effort to represent the current environment in config management. We're a big user of Ansible, and I don't know if anyone here was at my talk at WinOps last year, but I kind of went through kind of a little bit into detail how we kind of went about doing config management. But that's not to say everything was kind of bleak in 27. The devs had done an amazing job of kind of automating as much as they could around deployments. So things weren't bad. It was just that it was a very rigid, non-scalable system. There was some cloud usage as well, but that was mostly around like dev test machines. What we started doing in June 2016 was, yeah, like I said, it was this old service provider. That meant that getting a new server was actually, you started that operation by faxing the service provider, can we please have a new server? Wait 2 to 3 weeks, get approval, and you all know that story. It was not very dynamic. So what happens then? Devs tend to just use whatever's already there, which cause this microservice monolith architectures. So the point I'm driving like today is that by moving our services to the cloud, we went from 3 weeks to 14 minutes in terms of scaling up. Like how long does it take from you decide to, yeah, we need capacity, until that kind of new thing actually accepts traffic and code is deployed and it's monitored and all of that. When I started in June 2016, we had some kind of provisioning projects going. It was completely manual. No one actually knew what was going on. This was pre-Ansible. In October 27, we had this need to like scale up rapidly because we started delivering HBO through our platform. And Game of Thrones is another, like, in addition to cross-country skiing, Norwegians are really fond of Game of Thrones. So the fax bypass was basically us asking our service provider, hey, can we just give you this blanket authorization so you don't have to like require a fax every time we need a new server? And they reluctantly said yes. So we got the provisioning process down to 1 to 2 days, which was really awesome. It was like champagne time at the office when we did that. In November, we moved our first API to Amazon. So we took all of this config management kind of code that we'd already written during the last year and basically just provisioned that on top of Amazon VMs. So that was also like a big move. And in June of 2018, we moved the heaviest API that we have to Amazon. And by then, we'd kind of optimized the process a little bit. So a scale-up or a provisioning process was down to 45 minutes. We still kind of applied all of the code after the VM was deployed. And then now, by November 2018, we're down to 14 minutes. And those numbers might not mean so much like isolated, but I'll come back a little bit to why it's important to kind of keep driving down that number. So like I said, the step one was basically we need to be able to describe every server, every service in code. We can't have any like manual step here. And this was my talk, as I said, last year, where we basically reverse engineered years and years of manual change and tried to like bring in some standardization around how we automate the platform. And that took us a good year. But at one point, we could say that, yeah, every single service, every single server is now like described in config management. That's awesome, but kind of what do you do from there? So we started moving things into Amazon, and before I kind of go to town on that stuff, I just want to quickly share a slide on how traffic kind of is routed from our users into our services. So since we're on Amazon, we use application load balancers. All cloud providers have some kind of load balancer. But maybe the interesting part is that we don't send traffic from the load balancers directly into the VMs. We have this, we call it like the edge load balancer and the inner load balancer. And this is a layer that runs on Linux machines, and we use a load balancer called Traffic. And Traffic is pretty awesome. You can manually kind of manipulate the routing rules, but you can also plug in different types of providers. So we use Console, which is a service discovery tool to kind of provide rules into traffic. So what happens is that when a VM comes up, it starts health checking itself. And if it's good, it'll start get traffic. And the minute it's unhealthy, it stops getting traffic. And we do that health checking every couple of seconds so that a failure is kind of quickly alleviated simply by not sending traffic anymore to that VM. And that fits very well into this kind of rapid provisioning model that we try and build. So after we had everything in Ansible, for a while, and this was maybe last summer, for a while I tried to be this .NET Core, Docker, Linux, all the things advocate with the dev teams. But actually, after being at WinOps last year, I decided to stop moping and just instead build a kick-ass Windows platform framework, because it's going to take us years and years before we're able to kind of get rid of all our .NET Classic code anyway. So instead of kind of moving against the grain, we decided instead to just take the challenge and build a really, really good Windows platform. That's not to say that we hate Kubernetes. We actually love it, but that's another talk. So we came up with some design decisions. The one was that VM images should be dumb and really generic. So we didn't want to manage 150 different VM images where you'd have to, that just didn't make sense for us. So we wanted really generic VM images. We also said that a VM image should be generic in that it's not connected to prod or dev or a separate service, and obviously no secret into those VM images also. We wanted to control everything through VM or instance, as they're called in Amazon, tags. So the tag you spin up a VM with kind of controls the config it gets. We wanted clear ownership. So every server and service at RiksTV has an owner for the stuff that runs in Amazon. We don't want unclear kind of models. So if there's a problem with anything of our Amazon estate, we can pinpoint that to a team. And the last one is maybe a strange one, but we talk a lot about provisioning in these talks and automation and kind of spin up things. But what happens when you delete? If you don't kind of design that process, most of the time you end up with some residue. And that can be like an agent that's still in monitoring, but it's not actually there. Or you have to go into your deployment tool and kind of manual delete stuff. So as part of this design, we also designed the deprovisioning of things. So we've said that provision plus deprovision equals 0. There shouldn't be any trace of that thing in there. So then we plugged in our existing Ansible code into this provisioning process. And we figured also out that we needed to build a few microservices for this to work. The first one was a microservice that essentially just gives VM names. Amazon is able to use, it has these auto-generated names, which is essentially the IP address of the server. But it's not really nice. And we wanted to provide VM names that kind of reflect or to kind of describe the servers somewhat. So for example, a dev server is named differently than a prod server. But it needed to be an automated thing. It couldn't be a guy called Peter that would sit in a corner and provide names. It had to be something automated. And also, we thought a lot about how to store credentials. Because as we run Ansible, Ansible has to be able to kind of log into these servers and provision them. We decided not to use Active Directory because we don't think we need it. So instead, we have this service that basically securely stores auto-generated VM credentials using Amazon KMS, which is this encryption thing. So that's things we had to build. So this is essentially our provisioning process. And it's the same process whether you scale up or you create something brand new, everything is exactly the same. So this request ASG increase is basically just, you have 2 servers, there's Game of Thrones, we need more servers, what happens? So I thought I'd quickly talk through it, and then some of these boxes are represented by things I'll demo a little bit later on, so I won't go too deep into it. But essentially, we use CloudFormation, which is kind of Amazon's version of Azure ARM templates. So it's essentially you define in code how cloud resources should be spun up. So when a VM comes up, it already comes up with the right kind of tags and things, and it runs this really thin script. This is a PowerShell script, and we actually run PowerShell on Linux as well, so it's the exact same code for both Windows and Linux machines, so that's really nice. Good job, Stephen. So the first thing it does is that it asks the VM name generator microservice for a name. It says, OK, I'm dev, I'm this and this API, give me a name, which it gets back and kind of applies to itself. And then it auto-generates username and password. The server does this, and then it sends that to the instance credential server, which stores it securely. And then the third box is basically it asks Ansible Job Service, which is like our provisioning engine for running Ansible task to configure it. So Ansible does that, and as part of that, it installs the deploy agent. We use Octopus deploy, which triggers this whole software deployment scheme, which again kind of lights up the Consul agent, the service discovery agent, which again kind of starts sending traffic to the instance. One thing also, we're really concerned with what we call the sad path. I mean, everything is fine when everything works, right? And you kind of, everything is green and things are good. But things fail all the time in this system. And instead of us kind of, we kind of welcome that failure. So we spend a lot more time designing for failure in these automation systems than we spend with like the happy path. And it's at the level where kind of almost every line of code in my team is kind of discussing how should we handle, what if this throws, what happens, should we crash, should we report it to the crash reporting service, what should the path be if we fail here? Amazon provides these lifecycle hooks. So basically, when a VM comes online in Amazon, it also triggers this. You can almost call it like a pending confirmation. So how it works is that the VM has to prove that it's good. And it's just an API call, and you can use it for anything. But essentially, the last part of our process is that we send a confirmation call to this lifecycle hook saying, yes, the VM is good, code is deployed, it's getting traffic, this is good. If Amazon doesn't receive that, it'll actually terminate the instance. So if anything fails that we kind of didn't pick up in our system, the instance will be deleted, and it'll just try again with another one. So that's essentially how things work. So I talked about Ansible Job Service, and it's this REST API that we built that essentially just it receives jobs, so you can ask it to, hey, apply this Ansible playbook against this node. So it receives job triggers, and then we use Kubernetes. So we actually run Ansible inside of Docker containers, which is provisioned by Kubernetes. So Ansible Job Service talks to the Kubernetes API, and then we use, these are just details. But again, we have a lot of verification logic to ensure that failed jobs are also handled. And again, I find failure a lot more interesting than I find success. Success is simple. So I'm gonna attempt to demo a little bit. Maybe have one more slide. So this morning, one of my team members approved a pull request that introduces like a 50% failure rate in the provisioning process for this fake API, which is my team's API, which doesn't do anything other than allow us to test stuff. So this means that around half of the time we actually fail, so that we can look at how that would work. So let's see if this thing works or doesn't today. So this is an, I guess, how many are familiar with Amazon tech? Oh, okay, so good stuff. So it's not that different from Azure, and I'll try and kind of explain what this is. But inside of Amazon, you basically have this auto-scaling group, and an auto-scaling group has a scale. You set how many VMs you want, and that can be a static number, or you can say that it follows CPU usage or something. So this API is essentially static. So right now, I've told it that it should try and keep a capacity of 1. It should never go below 1, but it can scale up to 4. So let's do that. Let's give it, I don't know, 3. And now this demo, I'll go a little bit back and forth because we don't want to wait for a full 15 minutes for everything to spin up. But what happened now is that I basically told Amazon that I want 3 instead of the existing 1. So in a few seconds, it should start spinning up things. So this takes a few minutes for Amazon to kind of deliver the OS, and then from there it's up to us to kind of do with it as we please. So this is just another view of the same. The one already there is an existing VM. So this service is providing it can take traffic right now. And then the other 2 are coming online. Here we are. And as you can see, they haven't gotten a name yet. It's just a thing. Unlike in Azure, I think you have to kind of provide name, at least if you spin up machines outside of these auto-scaling things. In Amazon, you don't have to. A name is just an attribute. So these are coming up now without the name, actually. And then in a few minutes, we'll kind of see what happens. And then my hope is that at least one of these will fail so that we can kind of see that. Yeah, so while that's spinning up, at this point, the provisioning process worked really well, but it still took almost an hour for us to kind of, from we said scale up to code was deployed and the server received traffic. And that's not a problem in itself, but I think that what you want to design systems where you go from one controlled state to another, right? And while you're kind of fluctuating between those states, you have a higher degree of risk. So I think it makes sense to kind of, the lower you get that provisioning time, the faster you move from one controlled state, which in this case is 1 instance, to another controlled state, which is 3 instances. You kind of go from stable to stable. So everything in between, you might fail, you might not fail. And for us, we saw that for us to be able to provide just some simple buttons to dev teams where they can basically, if they want, they can scale from 1 to 20 without us caring. For us to kind of be really sure that that process would work, we wanted to drive down that provisioning time. And also, the less stuff you do during provisioning, the less risk you have. For example, we saw that since we installed packages with Chocolatey, the kind of public Chocolatey repo would sometimes time out, and that would kind of crash our provisioning. And a bunch of other things would fail as well. So we handled it nicely, but it was still something that kind of introduced risk that we didn't want. So what we decided to do, since we had everything in Ansible code, we started splitting up our Ansible roles into what we call build and deploy roles. So for example, we have a Datadog role that used to both install the Datadog agent and set up all the configuration that we do. So we split that up. So we have a Datadog build role that installs the agent, but just disables and stops the service. And then we have the deploy role, which is run at deploy time. And all that does is basically just injects the configuration file and starts the agent, which is obviously a lot faster than the full kind of thing. So this was essentially what we did. We took all of that code and split it up so that we built a lot thicker images, which placed the risk here at build time instead of at deploy time. So we kind of shifted left both on risk and deploy time. And that kind of took us down from 25 to 35 minutes to around, I don't know, 8, 10, 14. So let's see how my little demo thing is doing. Yeah, so it's got a name now. That's good. So I have 3 VMs. One of them was already existing, so I should have 2 jobs here. And devs kind of laugh at me a little bit. This is how it looks when SRE creates GUIs. It's basically Bootstrap, and then you just add ugliness, and you end up with this. But it works really well. So as you can see here, we have 2 kind of jobs in process. So these jobs are called from the instance itself. It tells Ansible Job Service that, hey, I'm such and such server. I have such and such tags, such as, for example, dev. And I need to be configured. I have no idea what the world looks like. I just know that I need a configuration. So that spins up 1 Docker container per kind of VM that needs to be configured. So here you can see it's already running. And these containers actually stream logs into Kibana so that we can get like a live view of how things are going. And that doesn't really look that good on a small resolution screen like this. But this is basically that kind of small block to the right in my presentation where all of the configuration files and starting up the agents that's needed and making sure console is running as it should, all of that. So this process now takes around 10 minutes. And as I said, I hope one of them fails because that would be awesome. Yeah. But then the next question was, OK, so we create all of these images, and we have this huge fleet of a couple of hundred servers. So how do we manage updates? How do we make sure that when we create these updated VM images every month or whatever, how do we ensure that they're actually used? Because a lot of these services in auto-scaling groups might never they might not get scaled down and scaled up that often. So there's a really good chance of basically us running stale images. So we could either set up Windows Server Update services, which I know everyone loves, or we could come up with something completely new. And we obviously decided to do the latter. So we built another service, and this is the VLS, the VM Lifecycle Service. So how this works is that since we build these AMIs, VM images, we typically build them every month. And Amazon provides, and I'm sure the other cloud providers do as well, they provide ready patched images. So if I'm building based on Amazon's kind of Windows 2016 image, I know that that's a good image. I know that it's been tested, and it has relatively updated kind of patch level. So we build these every month. And then whenever an image is built, we basically tell this VLS service that, hey, there's a new image now. And inside of VLS, it basically keeps track of all the kind of stacks, all the auto-scaling groups. And as you can see here, we have this workflow where typically the moment a new image is available, we'll start replacing the dev environments. We consider those not dangerous, and if there's a failure there, that's fine. We might get in the way of a developer getting his work done, but it's worth it because we need to test that. And then maybe a day later or a week later, we do the same thing for the prod kind of version of the same service. So that gives us this lead time where developers can test that no fault was introduced and everything works good and logging and monitoring still works and all of that. So this, I don't know how you can see this, but this is basically just the output log from the container that kind of executes this. So again, we are much more concerned with like the sad path or like what happens if something fails. So what we do is that we essentially tell Amazon to replace all the VMs, but we also make sure that it kind of returns to a green state, that everything's good. And we even go in on the VM instances and check that the instance or the kind of image it's based on is the one we expect. And if anything fails, we basically have this kill switch in the service that will halt all other deployments. So we'll basically stop at the first failure whenever there's a new image. And that provides a really kind of robust process. It's something we can trust, and it's something that developers can trust, that we don't just replace VMs willy-nilly without really testing it. Yeah, so let's go back to our little experiment here and see how it's doing. I'm so hoping one of these will fail now, because if not, I have to tap dance for 13 minutes. Okay, so what it's doing here, like this is one of the last steps. It's basically just creating the service account for Octopus, for the Octopus agent, and then basically just waits for the software to be installed. And what Ansible does now is that it sits and tests this health endpoint inside the API. And that's one of like the contracts we have between the infrastructure and the dev teams, that all services need a health endpoint that is known. And developers are free to put in whatever they want there. So it can just be like a dumb endpoint, which doesn't do anything. Or if they want to use that health endpoint to kind of verify that database connections or Redis connections or whatever are working as intended, that's fine as well. We don't really care. All we care about is that there is something that we can test to verify that the service kind of runs as expected. So this should trigger a deploy job in Octopus, which will kind of pull down and install software. And then we basically just wait. So one of three things can happen at this point. It could just sit there, something failed, and it'll just time out. This will cause that lifecycle hook I talked about to never be kind of completed, so the VM will just be deleted. That usually takes more than my 12 minutes, but that's one scenario. The other scenario is that we could like actively fail something, and Ansible Job Service will see that. What will happen then is that the system will see that, hey, this is a new VM. It's kind of not in production ready, so we're safe to delete it. It was never receiving any traffic at all. So we'll just get rid of it, and the system will try and provision a new one. And then the last path is like the happy path, where everything works, and console and traffic kind of starts routing traffic to the server. So that's a good sign. This means that we actually had a deploy. Sorry, bear with me for a few seconds here, and we'll see what happens. So now it's on like the final leg of its journey. And yeah, I guess I wasn't that smart. I should have introduced that failure a lot earlier in the process. That would have made for a more interesting demo. But anyway, we'll see what happens. I can maybe save that for last, and I can do my sum up things, and then we can spend the rest of the time looking at what's left of the demo. Yeah, so what kind of effects did we get? I don't know. This is the kind of uptime graph of our most critical service. And I don't know if anyone kind of dares guessing when we moved this into Amazon and to the new system, but it was in late May, which kind of aligns nicely with our uptime, except for that pesky network incident that Amazon had in September, which ruined our nice uptime. But that's out of our hands. So the system really works, and it's important for us to kind of show dev teams so that they see themselves that this is not like a theoretical thing, and we're not moving to the cloud because it's cool, but it actually provides us better uptime so we can deliver better services to our customers. And also, we have a lot cleaner separation of concerns. So where infrastructure ends and dev kind of ownership begins is really clean. It's defined in code. So there's no kind of doubt where what kind of the developer responsibility is. They have to provide a health endpoint, and they have to like provide a couple of other things in their code. And as long as they do that, then the infrastructure kind of takes care of the rest of it. And yeah, it's robust. It works really well, and all of those kind of sad code paths that we've put in our services make it kind of a non-issue to perform updates. So that feels really good as well. So stuff we learned: build robust systems. Google says that hope is not a strategy. We, since we're friendly Norwegians, kind of have a little bit more of a positive twist on it. So we say trust but verify. The next thing is integrate with, don't depend upon. And I think that's interesting when we build these microservices that kind of talk to Octopus, and they talk to Amazon, and they talk to a bunch of other things, that we create these loose integrations so that you're still able to kind of replace your monitoring without the whole rest of the system falling down. Next one, if it's scary, you're not doing it enough. The first time we scaled up that supercritical API, everyone was like cold sweating. I was like, what? But that's just a clear sign that we're not doing it enough. And now we don't even care. Developers themselves kind of decide what scale to run their services at, and we don't care. We fully trust the process to be robust enough. The next one is this build versus buy. You'll hear a lot that you should kind of buy what separates you from the competition and build. No, sorry. You should build what separates you from the competition and buy the rest. I think that's outdated. What we all are builders now. We just piece together different components. We try and find the best components, and then we build upon it. So I think it's kind of outdated. The next one is don't forget dev teams. Now that we move into this ephemeral infra world, there's a lot of developers who may kind of have been used to living with VMs that live for a year or 5 years or 10 years. And now suddenly we force them into this world where a VM or a container only lives for a few seconds or minutes. And that, you kind of have to respect that's a mental shift that you kind of have to help developers navigate. So we try, we're not good enough, but we try and kind of provide tooling and documentation and how do you deal with this world, this new world. And the last one, I think, is something we all can agree on. There's no benefits in moving to cloud if all you do is sit around in a portal and manually click buttons, although it could be really tempting sometimes. Sure, for research, but real cloud benefit comes from really, really rich automation. And that is actually my talk. So what I'll do now is that we'll just goof around with the demo a little bit. And if you have questions, I think we can do that a little bit in parallel, actually, because there's some slowness here. So yeah.
Any questions before we move with the demo then?
No, okay. So I can just explain quickly here what happened. So we had a scale up of 2 VMs, and as you can see, one of them came online. So there's 2 VMs providing this service now. The last one failed, and what we do if we fail is that we essentially retry the whole process once. And we do that just in case there's like a network glitch or just some small stuff we don't want to we want to be as lightweight as possible. So we retry everything once. And then if this keeps failing, it'll kind of just be, the VM will basically just be deleted and we'll spin up a new one and keep retrying. And that will happen for eternity if the process itself is broken. So it'll essentially never give up. And that's something that we have to improve in our monitoring, actually, because right now we don't kind of pick up that well enough if there's like this storm of pending machines that never kind of stabilize. So that's something we have to improve in our monitoring, so that we don't look at just the VMs that are up, but is the system like able to stabilize at the scale that we desire. But yeah, so again, we'll just have to see what happens with this guy, and it shouldn't take too long to figure it out. But I was kind of hoping there would be questions, because now it's still 4 minutes of awkward silence or me tap dancing. You don't want that. So it's questions or tap dancing. What's that? Oh, no, you don't. You definitely don't want to see that.
Here we go. We've got a real question. I hope this isn't, can we see you tap dancing?
So not actually related to any of this, but you said you're using a lot of very old .NET to, like we're the same. We still have web forms. We still have the old ASP.NET websites and all. How did your team find the upgrade, or as you're doing it? Did any pain points or little tips before we do it?
Which upgrade are you thinking about, or what?
So mostly the website upgrade. Right now we're on an old, it's a Visual Studio website, which depreciated years. Or I don't know what your websites are on. Are they on old ASP websites, or?
So it's mostly .NET 4 based web APIs, so just regular web APIs. But like I touched on, the dev teams at RiksTV already set up a really nice kind of deploy pipeline, so we didn't kind of have to reinvent that. We might do something else later, but sorry. But that was a part of the process that always was working nicely. So all we had to do there was essentially just add triggers to ensure that whenever there's a new kind of VM coming online, that it gets the same code as the other kind of service in the same farm or auto-scaling group. But that was kind of already in place. But we essentially use just completely standard Octopus deploy. So it's not any magic there. Yeah. I need one more question for the timing. Oh, hey, our friends from Germany. Thank you, sir.
Quick question. The auto-scaling stuff that you got there, is that the same for your databases, or is that just for your web front end?
No. And that's another maybe learning I should have added. But once you kind of move into this ephemeral world, you become really conscious of, does this service have state? Does it need to persist data in any way? We had some servers that kind of expected writes to the file system, that those files would like always be there. So that actually took a little bit of refactoring and something we kind of collaborated with the dev teams owning the service, that we kind of, you need to be able to, or you can store temp files and whatever, but you can't like assume that just because you placed a file on the file system that it's going to be there for eternity. So you need to use either like DynamoDB or regular databases or S3 buckets or something outside of the VM. But as far as databases go, we still use mostly SQL Server, which is running in this other Amazon service called RDS, which is, I guess it works like a light PaaS, so it's not as abstracted away as it is in Azure. But you can still like scale it up and down, and you can say that I need more capacity. So it works really well, actually. Yeah. Yeah, there was one more question here.
Yeah, I think we've got time for one last question.
Yeah. Oh no, the retry actually succeeded. Darn it. So I have 3 instances in my fake API now, and it provides absolutely no value. But that's how it is, I guess. Yes.
So first, Austria is not Germany, but I'll forgive you
Oh,
that.
sorry about that. Sorry.
Not a problem. You were, at the graphic you had earlier, you were telling that you're using the same PowerShell script on both Windows and Linux machines, and I was wondering what's inside the script, so what you're doing with that, and also if there's any chance for you to share parts of the workflow, because it looks like you've really built up a stack of useful utilities and scripts that help to integrate with maybe a lot of different environments.
Yeah, we have thought about it. We might be able to. We have this refactoring of the Ansible Job Service coming up. We have refactored some of it. The REST API itself is still planned to refactor because there's a lot of, my team calls it Tron code, and I'm not sure if that's a good or bad thing, but I'm assuming it's a bad thing. So we might try and kind of componentize the kind of RiksTV specific stuff in such a way that we can at least open source most of it. Because there's a lot of, it could, I can see that it could provide value for others as well. Right now it's tightly integrated with like the autoscaling group stuff in Amazon, but that's also like still in a separate module, so you can just disable that integration and the rest of the service will still work. And then obviously you'd need a Kubernetes cluster because that's how we kind of spin up containers, which actually runs the Ansible job. But yeah, it's definitely something we would at some point would like to do. Yeah. Unfortunately, it succeeded on its retry, so I can't show you any like deleted VMs. But maybe next time I should be so lucky. Thank you so much for coming.